Welcome to Spring LIB.
31.88. So we have an oscillating LC circuit. We have an inductance and a capacitance. We're told that our sort of initial condition is that the current is at its maximum at 0 time and that it's 12 milliamps. So we want to find the maximum charge that gets stored on the capacitor, and then we want to find the earliest time and the value of the maximum rate of change of the energy stored in the capacitor, the power. So, part A. The maximum charge is going to be the current amplitude divided by omega. This equation is 31-4 and 31-14. And so we know that omega is 1 over the square root of LC, so 1 over omega is the square root of LC. So we know all of these things. And so the maximum charge the capacitor ends up storing is 1.27 microcoulombs. So we know that the potential energy stored in the electric field of the capacitor is 1 over 2c times q squared. Q, we know, is going to vary with time sinusoidally. So we have our charge sort of amplitude here over 2c times the sine squared of omega t. So now, in order to find the earliest time at which this is a maximum, one way we can do it is to differentiate it and set that equal to 0, and that'll tell us the maximum. So let's do that. And so we're going to get a 2 sine omega t cosine omega t from using the power rule and chain rule on this. And that's equal to sine of 2 omega t, because it's the trig identity. We get an omega out from the chain rule, sine of 2 omega t. So the maximum value occurs when sine of 2 omega t is equal to 1, which means that the times we get are going to look like 1 over 2 omega times n pi over 2, where n is an odd integer. And for n equals 1, which will be the earliest, we get 8.31 times 10 to the negative 5th seconds. So that happens pretty quickly. And again, to evaluate this, we can use the fact that we already know 1 over omega is the square root of LC. Although, I mean, you could also just evaluate what omega is and write it down and then use it here. And, it doesn't really matter that much. So looking here at the power for the capacitor, in order to get its maximum value, we don't have to worry about any of this. We just know that the maximum of the only part that varies with time is 1. So that's going to be q squared over 2c omega. So this is like I, the square root of LC. We determined that was the charge amplitude over 2c times 1 over the square root of LC. So we end up with I squared over 2 times the square root of L over C. And this is 5.44 milliwatts.